In this video, we're going to introduce and prove the second part of the fundamental theorem of calculus. Now, for this one, we will use the mean value theorem. Remember that I told you that it was very important and that we were going to use it to prove the fundamental theorem of calculus? Well, it is going to appear here. I hope you'll manage to spot it. Okay, so let's get started. Well, the second part of the fundamental theorem of calculus tells me that if f is continuous on the closed interval ab, then the integral from a to b of f of x dx is equal to g of b minus g of a, where g is an antiderivative of f, meaning that g prime is equal to f. Okay, so we often use the notation like g of x bar like ab to mean g of b minus g of a, or g of x like ab to mean g of b minus g of a. So this very often then turns into what we do when we're computing integrals, which is that the integral from a to b of f of x dx is equal to g of x bar like ab. Remember here, g prime is equal to f. This is actually what you do when you compute integrals. Now we're going to just justify it. Well, we know that g prime is equal to f, and we want to show that the integral from a to b of f of x dx is equal to g of b minus g of a. Okay. So we're going to first define big F of x to be the integral from a to x of f of t dt. Okay? Now, since f is continuous, we can use the first part of the fundamental theorem of calculus, and that tells me that big F, the derivative of big F, is equal to little f. Good. But then we also know that the derivative of g is equal to f. So that tells me that the derivative of big F is equal to the derivative of g. But then that tells me that the derivative of f minus g is equal to 0. But then that would imply that my function is constant on that interval ab. Try to think about why. But now, if the function is constant, that means that there exists a constant c, such that f of x is equal to g of x plus c for all x in the interval ab. Now we just need to find the value of c, and because it's constant, I can pick any point, and that will tell me what the constant should be. So if we evaluate at x equals a, we can figure out the value of the constant. Now, f of a, big F of a is 0, because that's the integral from a to a of f of t dt. So the width of my region is 0, so there is no area there. So we know that big F of a is 0, but big F of a is also going to be g of a plus c. So that tells me that c should be minus g of a. Okay, so then that tells me that for every x in the interval ab, f of x is equal to g of x minus g of a. Good. Now, the integral from a to b of f of t dt, or it is a dummy variable, so it's the same as integral from a to b of f of x dx, is f of b. Oh, but f of b is g of b minus g of a, and that is exactly what we wanted to prove. And that completes the proof of the fundamental theorem of calculus, and that is the end of this playlist.